G'day guys, it's Mr. Bennett here. We're going to have another look at a second example for the polynomial first principles. So this is method number 1. Alright, so here's my question in terms of I have to find what the derivative of that is by first principles. So we know f dashed of x equals the limit as h goes to 0 of f of x plus h, take f of x all over h. Now that is that's the actual formula for that. Alright, so what I need to do is, where I see our x terms, I need to put an x plus h in here and work that out. So that's equal to the limit as h goes to 0 of x plus h cubed plus 2 lots of x plus h plus 1, and then I have to take away f of x. So make sure you put a bracket around this so you don't lose the negative sign as you take it through every term. Alright, so and then that's all over h. Now I don't know how good you are at expanding something with terms like x plus h cubed, but I'm going to show you a little technique that you can use which I think is quite good. Alright, it's called Pascal's triangle, and I'll do that in red up over here. So Pascal's triangle, he was a very famous mathematician, and this really makes life easy for you. Now we don't generally go much more than about to the power of 4. So the triangle looks a little bit like this: 1, 1, and then it goes 1, 2, 1, then it goes 1, 3, 3, 1, 1, 4, 6, 4, 1. So in terms of this is, right, this is my x squared term, that's my x cubed term, that's my x to the 4 term. So if I was looking at that one there, that's going to be x squared plus 2xh plus h squared. This one's going to be x cubed plus 3x squared h plus 3xh squared plus h cubed. I don't know if you've worked out what's going on, but this power here, the x power is decreasing by 1, and we don't write the h to 0 in there, we don't write the x to the 0 in there, and then the h term is h to the 1 increasing by 1 each time. Alright, so this next term will be x to the 4 plus 4x cubed h plus 6x squared h squared plus 4x h cubed plus 1h to the 4. Alright, so hopefully you get that. I've rushed through that, but if you want to ask me about that in a little bit more detail, I'm happy to go through that with you. Alright, so when we come to this example over here, alright, that's what I'm going to use. I'm going to use Pascal's triangle. So the limit as h goes to 0. Now, this is really good, this stuff. You can look like you're really intelligent with all your mates at school. Right? They're going to see you do a page of work. They're going to go, oh, what the hell is he doing? Right? So, and you can say, oh, this is really hard and I'm really intelligent, but this is actually pretty easy once you get the hang of it. Alright, so let's treat this first term. Alright, we'll treat this first term as a calculation. And so what we're going to do here is we're going to go, that's x cubed plus 3x squared h plus 3x h squared plus h cubed. That's that first term. Right, that's there. I'll colour code it for you so you can see what I'm doing. Right, so the next term is going to be, just expanding that bracket, 2x plus 2h plus 1, and then I'm going to take the negative signs through the bracket out there. That will give me negative x cubed negative 2x. That's why it's really important to put the bracket there, otherwise you'll lose the negative. and then take 1. And then that's all going to be over h. Now the key concept of what we're trying to do here is get every term at the top to have a h with it, so then we can cancel the h down on the bottom one. So now we go through and look at the terms that we can cancel. Now any term that doesn't have a h with it should cancel, and then probably even some of the h terms might. So that cancels with that. Alright. The -2, the +2 cancels with the -2. Alright. The 1 cancels with the -1. Now I'm looking for all the other terms here, they've all got h's in them. So then what I can do is I can say that's equal to the limit as h goes to 0 of h. Now bring out a common factor of h, that'll leave me with 3x squared plus 3xh plus h squared from that term there plus 2. Okay, and then that's the h on the bottom line. Right, and then I'm now in a situation where I can write this limit as h goes to 0 of 3x squared plus 3xh plus h squared plus 2. Now what I'm really doing here is taking the limit. So in other words, I'm actually making h equal to 0 now. Alright, that's what I'm effectively doing. So therefore f dashed of x is equal to 3x squared. Now that's going to go out because that's got 0 times 3x is there, and that will leave me with plus 2. Alright, so that's my answer. Now again, if I wanted to work out what f dashed of -3 is, then that's going to be 3 times by -3 squared plus 2. -3 squared is 9 times by 3 is 27 plus 2. So that's going to give me an answer of 29. Okay, so you get the concept that you can put any value of x in there and you can find out what the actual slope of the tangent is. Now, the steps that we're going through, right, we expand. Okay, the key step is we expand each term. We collect like terms. And remembering what we're trying to do there is at this stage here is have no term with a h in it. Okay, every term has to have a h in it, and then we can cancel the h's out, cancel the h's out, and then take the limit. Okay, so those are really the 3 steps that we're doing there. So if it's a polynomial, you know that's what you got to do. You got to FOIL it out, expand it out, collect your like terms. We know at this stage here. Okay, this stage here is really important. Okay, we know that we have done it correctly if every term on the top line has a h in it, and we can take a common factor of h out. If that's not the case, then we know we've made a mistake, and so therefore we can trace our way back and find our mistake. Now, every year when I teach this to students, right, well, I have a percentage of students that don't get this, right, which is really sad, because once you do get it, it's actually quite easy. Right? It looks very complicated, but you know, we're doing one step at a time. It's one of those sort of things that, as I said, you can look smarter than you really are by, you know, your friends who see you doing this won't actually have any idea what you're doing, and so you can tell them it's really, really hard and that you're really, really smart, and I'm sure they'll appreciate that. But you know, if we look out for the things that can go wrong and what we have to know about, then we can actually make sure we always get it right. So here, common mistake that people make is they don't put the bracket around here. Right? So you got to make sure you put your bracket around that term. If you don't, the chances are you'll lose your negative sign, and that's where people can't cancel things out on this next line. Alright, so just be aware of some mistakes that can happen, and good luck with those, and you're going to need to practice some of those. Now, I've listed on your sheet that you've got there the questions that I'd like you to have a go at doing. Alright, good luck with them. Make sure you catch up with me in class if you need some help.